Hello, Accelerated Chemistry students. This is Ms. Krista Foley, and this is your Chapter 3, Section 2 video notes, and it's entitled Units of Measurement. So let's talk about using SI units. First, metric units are standard measurements used in science, and all metric units are based on multiples of 10. And because they're based on multiples of 10, it is easy for us to convert between these units. Now, the metric system was originally established in France in 1795, and since then, an international system of units, or SI, was made, and it was a revision of the original metric system. And the System International, or SI, units were adopted by international agreement in 1960. And so this is what all scientists use in their measurements. There are 7 base units. They are in this table, and this table is also found on page 74 of your textbook. You need to memorize these. Know that length is a meter, and mass is a kilogram, temperature is a Kelvin, and so on and so forth. And you also need to be able to identify what symbol goes with which. So I would make flashcards for those. So from the base units, all other SI units of measurement can be derived. So you can derive volume, density, and pressure from all of those base units. Now, when we're talking about units of length, for example, some people use the basic unit of length as the meter. And sometimes there are very large or very small lengths. So we use prefixes in order to help us really give and signify how big or how small that actual quantity is. So here is your prefixes that you need to memorize. You need to know what the prefix is, what the symbol is, and what the factor. Notice that from deci down to pico, those exponents are negative, which means that those numbers are extremely small. And we're going to use these over the next few days in class so that you'll get familiar with them and know how to use them to convert between units. But the biggest thing you need to do to start off with is you need to have these memorized. So prefix, symbol, and factor. So let's look at units of volume. So volume is the space occupied by any sample of matter. And so if we're talking about a rectangle or a square, we know that volume is equal to the length times the width times the height. So the unit for the volume is going to be dependent on what those units of length were taken in. So for example, the cube in the bottom right was measured in centimeters. So if we take a centimeter times a centimeter times a centimeter, the unit for that volume would be centimeters cubed. What if we were talking about more units of volume? So the SI unit for volume is a cubic meter, and more convenient unit of volume is the liter, because that would be for a liter would be for something that's a liquid. So a liter is the volume of a cube that is 10 centimeters along each edge. So 10 times 10 times 10. So 1,000 centimeters cubed is equal to 1 liter. Or we could also use these relationships. Now, these are units of volume. So these are common units that we use to measure volume. And so for this, you need to memorize the unit, the symbol, and the relationship. So you need to know that 1 liter has 1,000 milliliters in it. 1 cubic centimeter is equal to 1 milliliter. And 10 to the 6th microliters is 1 liter as well. We'll get more familiar with these as we take more practice with these, but you need to understand what each of these are. So let's talk about units of mass. So the mass of an object is measured in comparison to the standard mass of 1 kilogram, which is the base unit for mass. So a kilogram was originally defined as the mass of 1 liter of liquid water at 4 degrees Celsius. So 1 gram is 1/1000th of a kilogram. So again, these are some metric units of mass. This table is also found on page 77 of your textbook. Again, you need to know unit, symbol, and what that relationship is so that you can use these in conversions properly. All right, let's keep going. So a lot of students get mass and weight confused, and I want you to be very familiar with what the difference between those two vocabulary words is. Weight is a force that measures the pull of a given mass by gravity. We're not in physics class. We do not talk about gravity in chemistry. So what I do want you to pay attention to is that we're talking about mass. We're talking about how much matter is in what we're talking about. So let's make sure we use those vocabulary words correctly. So the weight of an object can change with location. For example, if we were to go to outer space, the gravitational pull is less, so something in outer space will weigh less, but the mass of that thing will still remain the same. The mass of an object will not change based on location. So let's talk about units of energy. So the capacity to do work or produce heat is what the definition of energy is. So the SI unit for energy is joule, and that was created by James Prescott Joule, and he was an English physicist. And what we determined is the common non-SI unit of energy is calorie. So 1 calorie is the quantity of heat that raises the temperature of 1 gram of pure water by 1 degree Celsius. So what we did is we can convert between joules and calories, and we're going to do that by using the following relationship. So 1 joule is equal to 0.2390 calories, or 1 calorie is equal to 4.184 joules. Either one of those can be used to flip back and forth between the two units. And now let's talk about temperature. So temperature is something else that we can measure. So it's a measure of how hot or cold an object is, and it allows for us to determine the direction of heat transfer. So when two objects are in contact, heat moves from the object that is at a higher temperature to the object that is at a lower temperature. So the biggest thing that I want you to remember is that temperature or heat moves from hot to cold. So let's talk about temperature scales. Scientists commonly use 2 equivalent units of temperature. They use Celsius, which sets the freezing point of water to 0 degrees Celsius and the boiling point of water to 100 degrees Celsius, or they use what we've known now as Kelvin scale. And this came about by Lord Kelvin in 1824 to 1907, and he was a Scottish physicist. And this puts the freezing point of water at 273.15 Kelvin and the boiling point at 373.15 Kelvin. Now, the Kelvin scale allows for us to not have a negative value. So the 0 point on the Kelvin scale, or 0 degrees Kelvin, is what we call absolute zero, and it is equal to negative 273.15 degrees Celsius. Now, when you're looking at these two, you need to make sure that you understand that these two quantities are 100 degrees apart. So both of them will make sense. 0 degrees Celsius freezing point of water, 273.15 degrees Kelvin freezing point of water in the Kelvin scale. So there are temperature conversion equations that you need to memorize. Here they are. So Kelvin is equal to your Celsius temperature plus 273, and Celsius is equal to your Kelvin temperature minus 273. So we've got equations, so let's try our problem. So we're going to convert between these temperature scales. So the normal human body temperature is 37 degrees Celsius. What temperature is this in Kelvin? Now, this is a 3-step problem because it is a math problem. So first, we're going to list our knowns and unknowns. So we know we're going to need to use the equation. So our knowns are that the temperature in degrees Celsius is 37 degrees Celsius, and we're looking for what that temperature is in Kelvin. So we know we're going to have to solve for this, so we're going to have to use our equation. So let's plug in our values. So we know that 37 degrees is our known temperature in Celsius, so we're going to add 273 to that. And so our Kelvin temperature is 310 Kelvin. So now, does that make sense? And it should make sense, because you should expect this temperature range, since the freezing point of water is 273 degrees Kelvin and the boiling point is 373 degrees Kelvin. And so body temperature should be in between these two values, which it is, 310. That makes sense. Now let's talk about another measurement that we have. So, and that is density. Density is the ratio of the mass of an object to its volume. And this relationship will determine if an object will sink or float. The density equation is equal to the mass of a substance divided by its volume. So let's talk about density units. So when mass is measured in grams and the volume is measured in cubic centimeters, the density units are going to be grams per centimeter cubed. And the SI unit of density is kilograms per meters cubed. So density allows for us to determine the identity of some substances because density is very particular for specific substances. So below, as we get smaller and smaller and smaller, notice how our mass amounts stay the same and our volume amounts decrease. And look what happens to our densities. Okay, we're increasing in density per mass per unit volume. So density is an intensive property. So that means it depends only on the composition of the substance, not the size of the substance. So what does that mean? That means that no matter how much aluminum you have, it's always going to have the same density. So because of different densities, though, we have certain things that can happen. For example, liquids can layer. So if we were to layer these things, corn oil is less dense than water, so it's going to float on top of water. Corn syrup is very dense, so it's going to be on the bottom, and then we will be able to create what we call a density column, and these things can layer. So let's talk about temperature and density. So if the temperature increases, the volume will increase as the temperature increases, and the mass is going to stay the same. Why does this make sense? If you increase the temperature of something, remember what's happening. Those particles are moving further and further apart, so they're going to take up more space. And so when that happens, you get a larger volume, your mass is going to stay the same, and so your density is going to get smaller. So as temperature increases, the density of a substance will decrease. Now let's talk about how we calculate density. We're given the equation, so let's try a sample problem. So we have a caliper penny that has a mass of 3.1 grams and a volume of 0.35 centimeters cubed, and we want to know what the density of copper is. So this is a three-step problem, remember, because it is a mathematical problem. So first, we're going to list our knowns and unknowns. So we know the equation for density is mass divided by volume. We also know that the mass of this is 3.1 grams, and we know the volume is 0.35 centimeters cubed, and we don't know what the density is. And the density units, though, are going to be in grams per centimeter cubed. The mass unit divided by the volume unit. So we are going to solve for our unknown, which is our density. So we're going to plug our numbers into our equation. Now, notice how both of these values have two significant figures in it. So our answer is going to need to have two significant figures in it as well. And that number on the top should be 3.1 grams. That was a typo. And so our answer is going to be 8.8571 grams per centimeter cubed. And we're going to round to two significant figures. So 8.9 grams per centimeter cubed. And remember, we've talked about significant figures and rounding based on calculations. So from now on, every single math problem you do for me, you need to have the correct number of significant figures in your answer, or I'm going to mark it wrong. So let's evaluate. Does it make sense? So a piece of copper with a volume of about 0.3 centimeters cubed has a mass of about 3 grams. So about 3 times the volume of copper is 1 centimeter cubed, and it should have a mass that's about 9 grams, because if you're tripling the volume, you're going to triple the mass. And so you're close to what your answer should be. So that does make sense. And that concludes your Chapter 3, Section 2 notes. I hope you enjoyed them. And as always, all of the information on these Google Slides has been acquired and adapted from Pearson Chem's 2012 edition of the textbook, Resources CD, and pearsonchem.com. Thank you.